Right, hello everyone, welcome back to another Math Your Day channel. Right, so in today's video we'll be looking at the types of numbers. Right, so it's vitally important that for all grades rather, to know this, as this has been done in grade 7 and up. Right, so for grade 12 you're most likely to encounter this on the question on paper 1. Right, on question 1, where they talk about integers, okay, where they talk about an integer, where they talk about real numbers, where they talk about the whole numbers, right? And then when they talk about the rational and irrational numbers, right? So make sure that you understand the types of numbers where they're asking, right? Let's say they say round off to the nearest integer, right? So if you don't know what's an integer, then how do you know where to round off, right? Or rather what you do in that case. So in this video we'll be looking at an overview, right, and explore the real number system, right? So we have what you know as a real number, right? So we have what is called real numbers, right? So real numbers, this can be divided into an integer, or rather a irrational and the rational numbers, right? So real numbers, irrational or rational numbers, doesn't matter, right? So you're gonna look at what is a rational and the irrational and irrational later on. Now just introducing to these terms. If you don't know these terms, make sure that you write them down in your notes. It's very important that you know these things, right? And then another one is what we have an integer or an integer, right? An integer. So here we have a negative integer and a positive integer as well. So yeah, but you're gonna look at these later on, right? And then we have what we call a whole number. And yeah, that's about it. When you get to grade for grade 12, when you get to university, they will introduce what is called the complex numbers, right? So the word complex, you know what's complex, right? The word complex means hard. But do not be scared. If you are grade 12 and you'll be doing engineering, you will be introduced to complex numbers, of course. So this is very easy, right? So complex numbers are numbers that a calculator cannot do, right? I'm not gonna do this because this is specifically for from grade if you are grade 8, grade 9, grade 10, grade 11 or 12. So this is out of their jurisdiction, but it's something like this here. So if I have the square root of -4, right? When you plug this on your calculator, you get a math error, right? Let's see. So if I say, well, square root of -4, you can see that here I'll get this math error here, right? This is what we call a complex number, because here the calculator cannot do this here, right? It cannot calculate this. But for engineers, well, if you major in engineer, you're most likely to encounter this. But let me keep the video short, and yeah, let us do these ones here on top, right? Let us start with the okay, so let's first start with a real number. Let's first understand what a real number is in that case, right? So from the word, you can see here we're saying real number, so meaning the number has to be real. In that case, it can be anything, can be a decimal, can be anything, but as long as it is real. Like in the case here, if I have can be anything, let's say the square root of 32, right? That's a real number. It's a number, right? It is a number, right? Let's say we have 8 is a real number. Negative 6 is a real number. It is a number the calculator can provide. But if you have negative 4 in the eyes of the calculator, this is not a real number, right? So this is here is not a real number. If I say, well, the square root of negative 4, that's not a real number. But if you get to, university, you're most likely to see these here, the complex numbers. But this for grade 8 to 12, this is not a real number here. So in today's video, we'll be looking at real numbers, right? So first of all, let's talk about the first one here. Let's talk about the positive integer, right? The positive integer or integer, whatever you call it. So first of all, positive integers are numbers that are used when we count things, right? You cannot say, well, I have 0.5 cats, right, living in the backyard, right? So you do not have 0, what things, but I do have 2 cats, right? Or kittens. I do have 3 books. I do have whatever you have, right? So an integer, a positive integer, are numbers that are used to calculate, or rather to count things, right? To count things. I have this amount of things. I cannot have negative amount of what negative amount. Rather, I cannot have negative 2 phones, right? But I do have 2 phones, right? Not a brag, but okay. So positive integer, that this here is what we use to count, or rather to count things, right? To count things. So meaning positive integer are numbers from 1 2 3, etc., right? Continuing, right? So positive integer again is a numbers that we use to count things. So make sure that you understand for grade 8. It's very important to know what an integer is. So these are things that we use to count things. So from 1 2 3, etc., right? Etc. there. Okay, yeah. So if you know that now, right, you notice that positive integer are things that, or rather, are numbers that are used to count things. So meaning starting from 1 2 3 4 5 6 7 8 9 10, and so on and so forth, right? Okay, so now what if we include a 0 there? Well, 1 0 2 3 4, and so on and so forth. Now when we include a 0, now we call this a whole number, right? When you include a 0, this is now called the whole number, right? Which is denoted as n 0 there, right? This thing here, it represents the whole number. So whole number starting from 0 1 2 3, and so forth, right? So this is what we call, this is what is known as, or this is what a whole number is, right? From 0 1 2 3 4 5 6 7 8 9 10 11 12. Now a positive integer, remember, that we use them to count things, the number of things, and then the whole number is from 1 2 3 4 5, so meaning 0 there is part of the whole number. Make sure that you understand this, guys. You are most likely to encounter this. There will be that complex question from question 1, paper 1, or whatever. It can be also in question 2, where you have multiple numbers. Let's say you have negative, we're in trigonometry, right, where you have multiple numbers, and then let's say they say the x is an element of what, of whole number. So meaning we're gonna exclude these values here, and hence we're gonna start from 0 1 2 3 and so on and so forth, right? So make sure that you understand what a whole number is. Make sure that you understand the term whole number, or rather what is a whole number in that case. Yeah, so make sure that you understand that, because I can say, well, x an element of whole number, and then you don't know what a whole number is, and then let's say on your x values you include -3 and negative 200 and all that negative numbers, meaning now your value, your answer will be wrong in that case, because you do not know what a whole number is, right? So please know what a whole number is. Write it down, no notes, whatever, paste it on the wall, but just know what a whole number is, right? Okay, so remember we talked about an integer. So what an integer is, an integer numbers from negative including the whole numbers, right? So if I say, well, from negative infinity, my bad, and negative infinity to positive infinity. Okay, so for grade 8, if you do not understand what I just wrote there, so what I meant is numbers from the negative, right? Numbers coming from the negative, say -2, -1, 0, and then you have 1, 2, and so forth, right? So this is what we know as the integer. Integer basically are whole numbers including the negative. Now we do not include the decimal or fractions here, right? So it's only whole numbers and negative numbers, right? And negative numbers, but no fractions and decimal numbers, right? And square roots and all that. So this is what you call an integer. Negative numbers including the whole number, right? So make sure that you understand the term integer in that case. So here they can say, well, round off your number to let's say I have 2.73, and I say round off your number, let's say x then is equal to that, and then I say round off this value to the nearest integer, right? Meaning that, well, this is greater than 5. You can see that it's greater than 5, and hence here we're going to add 1. Therefore x should be equal to 3 in that case. So make sure that you understand what an integer is, because you most likely to encounter it. They can say round off your answer to the nearest integer, and you do not know what an integer is, you are wrong, right? Even if your x value was correct at first sight, they say you got this value here, and they say round off your answer to the nearest integer, you left it like this, is basically wrong, right? So make sure that you understand the term integer is from negative numbers to positive numbers, right? Okay, so now that we know these three, let's move on to the next one. So the next one basically is the irrational number. The irrational number here. So you can see if I eliminate this here, I have the word, oh my bad, so if I eliminate this here, you can see I have the word ratio, right? So what the term ratio means, well, it means I have x over something. Let's say x over m, rather let me say n over m. This is what we call a rational number, where where n and m are both element of what? Of whole numbers, right? So, oh, my bad. So an integer is denoted as the capital letter Z, right? As the capital letter Z, right? Okay, so in this case I could say, well, m and n, okay, let me just move this. Well, n and m are element of what? Of integer. So meaning that n and m have to be, n has to be an integer and m has to be an integer. So you cannot say, well, 0, 2 and let's say 3. This here, it is not a rational, it is not a rational number. It becomes a rational number. Okay, let me just say 5 here, 5. Okay, so this here is not a rational number. It only becomes a rational number when we change it to 1 over 2 divided by 3, and then I can times this by 3, so I'll have 1 over 6. Now this here is what we call a rational number. This here, it is not, right? Make sure that you do not have a decimal. There is no decimal. When you're dealing with the rational, there is no decimal, right? There's no decimal number, right? Or there's no square root or anything in that case. I can't say, well, this here, square root of 2. Well, square root of 2, square root of 2 over 2. This here, it is not a rational number here, right? That is definitely not a rational number. Why? Because there's a this here is not a what? It is not an integer. So meaning it's wrong in that case, right? It's wrong. So make sure that you know what a rational number is. Please make sure that you understand the rational number. Yeah, I've explained it more in depth now, right? Yeah, so now let us talk about the opposite of the rational, which is the irrational number in that case. So when dealing with the irrational number, now is something that is irrational, right? Is irrational. So meaning this number is it's complicated to the fact that we cannot change it, right? To the fact that the calculator even give us a what do you call this, a simplified form of it, right? Like pi. Plug in pi, right? You get most likely to get 2 what is pi again? Damn. Okay, so like if you think about it, if I have the value of pi in that case, so pi is 3,1415. Let me see. I can see pi is 3,1415 something, right? But if you notice here, this is 3,141592,654. This number is not it doesn't end here, it continues and continues because the calculator is small, meaning this here is, it can only express, the calculator can only express that portion. But if you look at it on your laptop, on a bigger screen like a TV, you will see a bigger number, right? And if you project it on a bigger screen, on a much bigger screen, you'll see that this number does not end, right? It cannot be simplified. It cannot be simplified. Like if I were to say, well, change pi to a what? To a rational number, There's no way you cannot change pi to a rational number, and hence why it is irrational number, and hence why it is irrational, right? Hence why it is irrational in that case. Now let us look at the square root of 2. Well, square root of 2. The fact that the calculator, if I plug in square root 2 there, the fact that the calculator gives me square root of 2 as is, when I say equal to, it means that this here does not, it's a never-ending number, right? It continues and continues, but if I change it to a decimal, then the calculator simplifies it, or rather it rounds it off. Right? So this here is not the complete answer of that, and hence why when you plug this, we on a certain value, we do not really get the accurate answers, right? Our answers are not that accurate because this here, it is not the complete, or rather the square root of 2, the complete value of it, right? So that is what we call an irrational number, right? An irrational number. Yeah, so but going back and looking at the difference between rational and irrational, let's take pi for instance. So let's look at the difference here. We have pi here, and then here we have 3,14. Now here there's a huge difference between these two things here. This here is what is the irrational. This value here is irrational, and this one is rational. Now the reason why I say the 3,14 is rational, because I can change it to be in the form m and n, right? So if you plug this there, you calculate 3,14 to give me 157 over 50, right? They give me 157 over 50, but with pi, you see what I did there? I pressed here and I got this here. But with pi I cannot change it, right? It will always be a decimal number, right? And hence why this here is the pi, this here is irrational here, and 3,14 is rational. So I hope that you understand the value, rather what is meant by irrational and rational numbers. Yes. Okay. So basically, by rational, I mean that, okay, so if a number is rational, it means that I can manipulate the number to be a what? To be in the form mn, right? To be in this form here. So let us look at an example. Let's say I have 0,33 recurring. Let's say the tree is recurring. By recurring, meaning that I have 0,33333333. So without using a calculator, I can change this number to be m over n, right? I can change that number to be m over n, right? So let us see whether we can do that. So if I let this number be equal to p, whether I have 0,33333 recurring, right? So what I can do is I'll say, well, if I times both sides by 10, so this is my first equation here. So if I times both sides by 10, what will I have? So I'll have on this side 10p, and here on this side I'll have 3, 3, right? 3,333 recurring, does not end, right? Okay, so again, what if I subtract these two here? So I can say, well, 10p minus p will also give me 3,33333 minus 0,33333 does not end. So we notice that the 0,33 will move in that case, and here I will have 9p, which is 3 minus 0, that's 3. right? Then if I divide, meaning that I'll get P equal to 3/9, right? Which is the same as 1/3. So now you can see that I've changed this value here without using a calculator. So meaning 1/3 is also given as what? 0.3333, and so on and so forth. You can check that on your calculator here. Okay, let's say 1/3. You can see that here it will give us 0.333 recurring. So meaning this here is a what? Is a rational number. Why is it a rational number? Because I was able to change it to a what? To a to this form here, n/m, right? Where 1, we notice that 1 is an integer and the 3 is also an integer. So yeah, that's it for this video. Just hoping that you understand these number system here. Where they say, if they say round off your answer to the whole to the nearest whole number. For instance, if I have 2,735, if I say round off your answer to the nearest whole number, then you know that I have 3 here. So if I have 2,435, I say round off your number to the nearest whole number, you know that I will have 2 here. So make sure that you understand this here. It is very important for all the grades, right? Not just for grade 8s and 7s and 9s, but also grade 12. They might ask you this again. It might come in those that question 1 paper. That question 1 paper 1, it might come in. So make sure that you understand these number systems. So that's it for this video. If there's something that you didn't understand, or maybe I made some sort of a mistake or something, please comment down below. I'll definitely review and do another video on the number systems. So thank you for watching. I'll catch you later. Cool.